In the last part of this video, I talked about the purpose of a survey study. I said that the purpose of a survey study in psychology, or in another social science like sociology, is to learn about a population of people, like men, women, or college students, and to draw inferences about the population, to draw one or more confident conclusions about the population. And in the last part of this video, I also talked about the definition of a population. I talked about the definition of a sample, and I talked about what it means to take a sample from a population. I also talked about why researchers have to settle for collecting data from samples rather than surveying entire populations. So I'm going to move past that, and right now I'm going to talk about the idea of a representative sample in a little bit more detail, and then move ahead from there. In the last part of this video, I mentioned that a representative sample is a high-quality sample. It's what a researcher wants. If a researcher has a representative sample of a population, the researcher can use that sample to draw conclusions about the population and be confident that those conclusions are accurate. And let me talk in a little bit more detail about the definition of a representative sample. So a representative sample is a sample that has the same mixture or the same makeup as the population it came from. A representative sample is basically a mini population. It basically looks like the population. So sometimes when I teach this topic in class, I'll do a quick example on the board of taking a slice of cake. And first I'll draw a picture of a cake that has 3 layers. And the top layer will be, let's say, icing, the middle layer will be plain, and the bottom layer will be chocolate. So imagine that the 3 layers are icing, plain, and chocolate. And imagine that each layer is 1/3 of the cake. So you have the top third, the middle third, and the bottom third. And then what I'll do is I'll draw on the whiteboard I'll draw a line straight down through the cake, and I'll draw the line straight down vertically, and then I'll explain to the class that the slice that I've cut off of the cake is also 1/3 icing, 1/3 plain, and 1/3 chocolate, just like the entire cake. Just like the entire cake, the slice that I cut has a top third, a middle third, and a bottom third, and those sections are icing, plain, and chocolate. The only difference between the slice and the bigger cake is that the slice is much more narrow than the cake is. And I tell my class that that slice of cake is a perfectly representative sample of the cake because it has the same mixture, the same makeup as the cake. The sample, the slice, is a third, a third, a third, and a third. Well, I'm sorry. The slice of cake is a third icing, a third plain, and a third chocolate. And the entire cake is also a third plain, a third icing, a third plain, and a third chocolate. So the sample matches the population, and it's representative. But what I also do to follow up on that is I draw another line going diagonally through the cake. And this slice of cake is not a representative sample because what happens is the cake has a lot of plain, lot of plain at the top. It has a lot of icing at the top. It has less of the plain section and very little chocolate because it only has that little narrow corner of chocolate at the bottom. So what I tell my class is that's not a representative sample of the cake because it has, compared to the cake, it has too much icing and not enough chocolate. And if a person eats that unrepresentative piece of cake, the person might draw an inaccurate conclusion about the cake. For example, if the person likes chocolate, the person might think, well, this slice has very little chocolate, so I'm kind of disappointed. I don't think this cake is very good because this cake doesn't seem to have much chocolate. I don't think the cake is very good. Well, if that is the person's conclusion, the person is using a bad non-representative sample and reaching an inaccurate conclusion about the population, because the truth is that that the cake is actually a third chocolate, right? And if the person says, based on this slice, I don't think that the cake is very good because it has not enough chocolate, that's not accurate. So a representative sample leads to an accurate conclusion about a population. A non-representative sample leads to a biased or inaccurate conclusion about a population. And a researcher will want to get a sample that's as representative as possible, so that the researcher is likely to reach accurate conclusions about the population. And the researcher can make confident inferences about the population. So here what I'm just saying is, if a population, like a university or any other population, is 45% male and 55% female, then a representative sample would also need to be 45 and 55%. So imagine a certain university, hypothetically, is 45% male and 55% female, and I take 100 people from that university and I survey that sample of 100. For my sample to be representative in terms of gender, I would need to have 45 males and 55 females, right? That adds up to 100. If my sample of 100 includes 45 males and 55 females, then my sample is 45% male, 55% female, and the percentages match the bigger population, and I have a representative sample, well, at least in terms of gender. So right here I have an image of a representative sample that I made with just some shapes. I think this is just a good visual to look at. So here you have a population of, it looks like 18 shapes, and the population is a third red, a third green, and a third blue. The population is also a third circle, a third triangle, and a third square. And if you look down at the sample of 9, notice how the sample is also a third of each color, just like the population. It's a third red, a third green, and a third blue. And notice also that just like the population, the sample is a third of each color. The sample is a third circle, a third triangle, and a third square. So the sample, the makeup of the sample perfectly matches the makeup of the bigger population. So this is a perfectly representative sample of this population, right? The sample is identical to the population, just a smaller scale version of it. Now, in an actual survey study, a sample is never going to be perfectly representative, because a perfectly representative sample would need to match the population on every characteristic. It would need to match the population on things like age, height, weight, gender, income, IQ, and the makeup of a sample isn't going to match the makeup of the population on every trait imaginable. So what a researcher has to do is, well, try to get a sample that's as representative as possible, and also decide what the important characteristics are that are relevant to the study, and then ensure that the sample is at least representative on those characteristics. So if a researcher decides that gender, age, and income are 3 important characteristics that could affect his or her results of the survey study, the researcher will want to ensure that the sample is representative on those traits, definitely, and then on top of that, try to get a sample that's as representative as possible on all of the other traits that are out there. So, like I said, no sample is perfectly representative. However, a researcher will want to get a sample that's as representative as possible, because a more representative sample provides more accurate information about the population. Just like how that vertical slice of cake gives you a better snapshot of the entire cake than the diagonal slice will. And before we move on, I wanted to give a few examples of a non-representative sample leading to an incorrect conclusion about a population. And I'll start with a couple of really simple examples, maybe overly simple. And then after that, I'll provide at least one more realistic example that might be in an actual study. So here's my first example. If a researcher wanted to know the mean or average age of a university, the researcher wouldn't want to go to a freshman class full of 18-year-olds, ask them for their ages, and then calculate the mean age of the class, because the mean age of that freshman class is going to come out to probably 18 point something, maybe 18.2, 18.5, because it's full of freshmen. And the mean age of that class is almost guaranteed to be lower than the mean age of the university as a whole. The mean age of the university might be something like 21.5 or even higher. So, and that's if a researcher did that, the researcher would be getting an unrepresentative sample because the sample is all freshmen and the makeup of the sample doesn't match the makeup of the population. And also, that non-representative sample will lead the person to underestimate the mean age of the university and reach an inaccurate or biased conclusion about the university. Here's example number two. If a researcher wanted to know the mean hours that a student exercises per week at a certain university, the researcher wouldn't want to go to the university's fitness center and ask a bunch of people there, how many hours do you exercise per week, and then calculate the mean or average of that sample, because that sample is going to be full of people who go to the fitness center, and those people typically exercise more than average, which means that the mean of the sample is probably going to be higher than the mean of the entire university, because the researcher isn't getting any of the people who don't bother to go to the fitness center, right? So that's an example, another example of a unrepresentative sample that's full of one type of person, leading to an inaccurate conclusion about the population as a whole. And I said that I would try to provide at least one more realistic example. So let's imagine that a researcher was interested in the mean hours spent on social media per day of college students. The researcher was interested in what's the mean or average number of hours that a college student spends on social media per day. And let's say that the researcher goes to a variety of universities and surveys students on their social media use. The researcher wouldn't want to just survey day classes only. If the researcher surveyed in-person day classes only, the researcher will probably have an unrepresentative sample and a biased conclusion. And let me explain why. If a researcher only visits in-person day classes, then the researcher is getting mostly traditional age college students between 18 and 23 who tend to be higher in social media use. And the researcher isn't getting enough of the older college students who tend to take night classes because they're working during the day, right? And the researcher is also not getting any of the people who take online classes who might tend to be higher in social media use because they tend to gravitate more to online rather than in person. So the researcher's conclusion probably about the mean social media use of college students probably won't be accurate because the researcher is getting a limited variety of people by only visiting in-person day classes. So that's one other example that I just wanted to throw out there. So now let's talk about what affects the representativeness of a sample. So the representativeness of a sample depends on two factors. First, it depends on the way that the sample is selected, and it also depends on the sample size. So let me talk about why the way that the sample is selected matters. If you want to get a a representative sample, you should try to give all population members an equal chance of being chosen. And later on, we'll talk about how the best way to do that is random sampling, or taking a random sample. And the sample also depends, the representativeness also depends on the sample size, which means that a large random sample is likely to be more representative than a small random sample. Because when you take a big random sample, you're taking a bigger piece of the whole, right? The sample becomes closer to actually being the population. And there are different ways to take a sample from a population. There's different ways to select your participants, and the sampling methods that are out there fall into two major categories called random and non-random sampling. And in the next part of this video, what I'm going to do is define random and non-random sampling and explain the difference in general, and then go over a few different types of random and a few specific types of non-random.